So when we say the order of the differential equation, it is the highest order in the differential equation. So when we say the degree of the differential equation, the derivative should be in the form of polynomial equation. Now the slope of the tangent is given by dy by dx is equal to 2x divided by y square. So when we have e to the power log x, then the value is equal to x. So therefore the integral factor is log x. Hello everyone, a warm welcome to one and all. This is your Shruti ma'am lecturing in Vidhyaashram, the Temple of Excellence, Mysuru. So here we are revising the chapter Differential Equation. Let us see the weightage of marks from this chapter. So in this chapter, under part A section, you will be having one fill in the blank objective type question, no 2 mark, one 3 mark question, one 5 mark question, and under section part A, you will not be having any questions from this chapter. So overall, you can expect 9 marks from this chapter. So let us see objective type of question in the form of fill in the blanks here. So the first question is the order of the differential equation d square y by dx square whole square plus cos dy by dx is equal to 0 is. So when we say the order of the differential equation, it is the highest order in the differential equation. So we can clearly see the highest order is d square y by dx square, and hence it is 2. It's a second order derivative. So therefore the order of this differential equation is 2. Next. The degree of the differential equation d square y by dx square whole cube plus dy by dx whole square plus sin dy by dx plus 1 is equal to 0 is. So when we say the degree of the differential equation, the derivative should be in the form of polynomial equation. But here dy by dx is along with the sine function. So in such cases, when we have the derivatives under any functions, so the degree is not defined here. So therefore, the answer is not defined. Next question. The degree of the differential equation y triple dash plus 2y double dash plus y dash equals 0 is. So again here, the degree is nothing but the power of the highest order derivative, and here the highest order derivative is y triple dash, that is d cube y by dx cube, and the power of that is 1. So therefore the degree of the differential equation here is 1. Next, we'll move on for the 3 mark question. So basically you can expect 3 mark questions from variable separable method, that is solving differential equation or formation of differential equation using variable separable method. So let us look at the question now. Find the equation of the curve passing through the point 0, -2 given that any point x, y on the curve, the product of the slope of its tangent and y coordinate of the point is equal to the x coordinate. Clearly is given the product of slope of tangent and y coordinate. The slope of tangent is given by dy by dx and with y is equal to the x coordinate. Now we need to solve this differential equation. Now, so we'll get here dy y dy, I'll shift dx here, that is equal to x dx. I'll integrate on both sides. Then integration of y with respect to dy is y square by 2. Integration of x with respect to dx is x square by 2 plus c. Now since the point is moving through 0, -2, substituting the point 0 and -2 here, we can find the integration constant, and hence we can find the particular solution for the given differential equation. So here, if we substitute -2 whole square divided by 2, 0 plus c. So we will get c is equal to 4 divided by 2. So c is equal to 2. Now if you substitute c is equal to 2 here, then we'll get the equation as y square by 2 equal x square by 2 plus 2. Multiplying 2 throughout the equation, here we will get y square is equal to x square plus 4. So this is the required equation. Next. Find the equation of the curve passing through the point -2, 3 given that the slope of the tangent to the curve at any point x, y is 2x divided by y square. Now the slope of the tangent is given by dy by dx is equal to 2x divided by y square. Now separating the variables here, we'll get y square dy is equal to 2x dx. Integrating on both sides, we'll get this as y cube divided by 3. 2x square by 2 means x square plus c. Now let's find the integration constant. Since the curve is passing through the point -2, 3, we can put -2 for x and 3 for y. So that is equal to c. So solving this, we'll get 9 equals 4 plus c, or c is equal to 5. Substituting c is equal to 5 in the equation, we will get y cube divided by 3 is equal to x square plus 5, or y cube is equal to 3x square plus 15. So this is the required equation. Next question. Find the general solution of the differential equation e power x tan y dx plus 1 minus e power x secant square y dy is equal to 0. So now first let us separate the variables here. We have here e power x tan y dx, and let me write this as minus 1 minus e power x secant square y dy. Now let me take x variables to the left hand side, y variable to the right hand side. So e power x 1 minus e power x dx is equal to minus secant square y dy divided by tan y. Now let me integrate on both sides. Now using the substitution method on both LHS and RHS, here if we put t is equal to 1 minus e power x, then dt is equal to minus e power x dx. And in the same way, if I substitute some u is equal to tan y, then du is equal to secant square y dy. So in both cases, you can see this is in the form minus e power x dx can be written as dt divided by t, and here we have minus, so secant square y dy can be written in the form of du divided by u, integration. So now we can cancel negative on both sides. So this is log modulus t is equal to log modulus u plus c. So now here log t, so what is t here? 1 minus e to the power x, 1 minus e power x, and here u is tan, so log tan x plus c. So this is the general solution. Next question, we have the equations in the form of linear differential equation under 5-mark question. So either it may be on dx by dy form or dy by dx form. So you can expect one under part D section from linear differential equation in the chapter differential equation. So now we have solve x log x dy by dx plus y is equal to 2 by x log x. I need this in any one of the standard form, either dy by dx plus py is equal to q form, or dx by dy plus px is equal to q form. So now I'll divide the equation by x log x. Now when I divide, I'll get dy by dx plus 1 by x log x into y is equal to 2 divided by x square. So here p is equal to 1 by x log x and q is equal to 2 by x square. Now let me find the integration factor. It is e to the power integral of p dx. So e to the power integral of 1 by x log x dx. So now using the substitution method, this is dt by t form, which is log t, or we will get this as e to the power log of log x. So when we have e to the power log x, then the value is equal to x. So therefore the integral factor is log x. Once we found the integral factor, we can write the solution for this type of differential equation in the form y into integration factor is equal to integral of q into integration factor with respect to dx. Now here y into integration factor means y log x. So here q is given by 2 by x square. So we will get 2 by x square into log x dx. Here we have two functions and 2 is constant. I'll keep 2 outside the integral. And when we have log function with algebraic function, first function should be given preference to logarithmic function. So we have log x into 1 by x square dx. Now applying integration by parts on the right hand side, we have y log x is equal to 2 times. Let us apply integration by parts. Log x into integration of 1 by x square, which is minus 1 by x, minus integral of derivative of log x 1 by x, integration of 1 by x square minus 1 by x with respect to dx. Now y log x is equal to 2. Here we have minus log x divided by x. So again we have here minus 1 by x square. So minus, which becomes plus. Integration of 1 by x square is again minus 1 by x plus c. So we have y log x. So when we multiply 2 here, we have minus 2 by x log x. And again we have minus 2 by x plus c. So this is the solution. We can also take minus 2 by x as a common factor and write it as 1 plus log x form. Next, solve dy by dx plus y secant x is equal to tan x. X lies between 0 to pi by 2. So clearly the solution or the equation is already in the standard form of linear differential equation, dy by dx plus py equals q. So where p is equal to secant x and q is equal to tan x. Now let's calculate the integral factor, that is e to the power integral of p dx. So which is e to the power integral of secant x dx. Integration of secant x is log of secant x plus tan x. And here you can observe we have e power log again. So e power log x is nothing but x. So we will get the value secant x plus tan x. Now the solution, which is y into integral factor, integration of q into integral factor with respect to dx. So y into secant x plus tan x is equal to integral of q is tan. So tan x into secant x plus tan x with respect to dx. So if we solve here, this is secant x tan x plus tan square x dx. Now we do not have any standard integral for tan square x, but tan square using trigonometric identity can be written as secant square minus 1. So the equation becomes y secant x plus tan x equals integral of secant x tan x plus secant square x minus 1 with respect to dx. Now again y into secant x plus tan x. Integration of secant x tan x is secant x. Integration of secant square x is tan x. Integration of 1 dx is x plus c. So this is the required solution. Find the general solution of the differential equation x plus 3y square dy by dx is equal to y. So here we have dy by dx x plus 3y square is equal to y. I'll shift y here, then I'll get x by y plus 3y square by y means 3y. I'll shift dx by dy here. Then I'll convert this in the form of dx dy. I'll shift minus x by y. Then here I'll get 3y. So this is in the standard form of dx by dy plus px is equal to q. So where p here is minus 1 by y and q is 3y. So let's calculate the integral factor. Integral factor is e to the power integral of p dy. So e to the power minus 1 by y dy. If I keep minus outside, then integral of 1 by y is log y. So e to the power minus log y, or can be written as e to the power log 1 by y. So y power minus 1 means 1 by y. So evaluating this, we'll get the value as 1 by y. So integration factor is 1 by y. Now solution for this differential equation is x into integration factor, integral of q into integration factor with respect to dy plus c. So q into integration factor plus c. So x into 1 by y, q is 3y, integration factor is 1 by y, dy plus c. So we are left with x by y here, y cancel, integration of 3, or we can keep 3 outside, integration of 1 with respect to dy is y plus c, or we can write x is equal to 3y square plus cy. So this is the required solution. So basically in this chapter, you're supposed to concentrate on order, degree, variable separable method of finding the equation and solution for linear differential equation. We'll meet you in the next session. Until then, keep watching, keep learning, keep exploring. Thank you.